Let's now look at two examples where we're going to solve a higher order homogeneous linear differential equation. To make things easier, I've written down the general form of a higher order equation. Don't worry, it's not nearly as bad as it looks. And then I've also written down 3 steps that we can follow for solving an equation like this. Let's look at our first example. We have y triple prime minus 4y double prime minus 5y prime is equal to 0. The first thing that we want to do is substitute in that y is equal to e to the mx. For this type of equation, this is what our solution looks like. Substituting this in, we end up with m cubed e to the mx. That's because we have 3 derivatives, minus 4m squared e to the mx, minus 5m e to the mx is equal to 0. This gives us m cubed minus 4m squared minus 5m times e to the mx is equal to 0. And this gives us then that the only way it's going to be 0 is that if m cubed minus 4m squared minus 5m is equal to 0, because remember, an exponential is never equal to 0. In step 2, we are going to solve this equation. Notice that we can pull out an m, so let's do that. We have m times m squared minus 4m minus 5 is equal to 0. Let's factor this. This factors as m minus 5 and m plus 1. And this gives us that m is equal to 0, 5, and minus 1. So we have 3 distinct real roots. In step 3, we need to write down the general solution based on the fact that we have 3 distinct real roots. Our solution is going to be y is equal to c1 times e to the first m, which is 0 times x, plus c2 times e to the 5x, plus c3 times e to the minus x. This gives our general solution is y is equal to c1, because e to the 0 is 1, plus c2 e to the 5x, plus c3 e to the minus x. And there's our solution. Let's now look at our second example. This one's a little bit more complicated, but it's not too bad. We have the 4th derivative of y plus y triple prime plus y double prime is equal to 0. Let's begin by writing down our characteristic equation. I think after doing the first example, you can see that the e to the mx is going to go away. So we can just write down the characteristic equation, which is m to the 4th plus m cubed plus m squared is equal to 0. Now in step 2, we're going to solve this equation. We can factor out an m squared, and that leaves us with m squared plus m plus 1 is equal to 0. The m squared is going to give us that m is equal to 0 and 0. And then for this one, we are going to have to use the quadratic formula. Our solution is m is equal to negative b, which is minus 1, plus or minus the square root b squared, which is 1 squared, minus 4 times a is 1, and then c is 1, all divided by 2 times a, which is 1. So let's see. This is m is equal to minus 1, plus or minus the square root 1 minus 4, so that's minus 3, all divided by 2. So this is minus 1/2 plus or minus the square root of 3 over 2 times I, because of the negative inside the square root. Before we write down the solution, let's write down what type of roots we have. Over here on the left, we have 2 repeated roots. And then over here on the right, we have 2 complex roots. Our solution is going to look like this. We're going to have y is equal to c1 times e to the 0 times x. That's our first repeated root, plus c2 times x times e to the 0x. That's for our second repeated root. And then with our complex roots, we're going to have e to the real part, which is minus 1/2. So we have minus x over 2. And now we have to take into account the complex part, which is the plus or minus root 3 over 2. So this gives us c3 times cosine square root of 3 over 2 times x plus c4 times sine square root of 3 over 2 times x. We can then rewrite our solution as y is equal to c1 plus c2 times x. That's because e to the 0 is 1. And then we're just going to recopy this last part. E to the minus x times c3 cosine root 3 over 2 times x plus c4 times sine root 3 over 2 times x. And there's our solution.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.